Good evening, my dear NEET warriors. This is your Captain Shreyas, your physics master teacher on the Vedantu NEET English channel and taking up the RNA series, which is the Roar NEET Aspirant series for free for all the students on YouTube in English. And we are on to the next chapter, which is the center of mass and the motion of center of mass. And things like, just take any object around you, and when you would have tried to balance it, right, the concept of center of mass is at play over here. If I hold it here, probably it doesn't get balanced. Maybe I need to hold it somewhere here so that this particular object will be balanced. So how does center of mass work, and how will it move, and what are the different aspects involved when it is in motion? That is what we are going to study in today's session. So get ready with me, your Captain Shreyas, your physics master teacher on the Vedantu NEET English channel. Hi Sukanya, hi Madhumati, Disha, Krishna. Hello everyone. Good evening, and say everything that you want in the chat box, because only then we will get to know each other. You will make friends, I will get to know you, so that next year when you are in AIIMS or in a good college, I would know when you say hello to me, sir, I'm in this college, I'll remember, yes, you were that student on this channel watching all the classes. And those of you who do not know about where to find all the lectures, let me remind you, it's there in our, where is it? Treasure box. I think the treasure box should be somewhere here. I think it is not there here. I'm not sure why it is not there. But anyways, the playlist should be there. The playlist should be there right over here on our homepage. The entire playlist is right over here. You can watch all the classes, okay, all the previous classes which you might have missed. It's there in the physics playlist, chemistry playlist, biology playlist, everything is there. If you have missed any classes, okay, and there is this treasure box also where I have uploaded all the PDFs, etc. together, okay. So make sure you check that out. I will get that link also added. Okay, let's begin. Hi Rajesh, hi Sneha, welcome Jasmine. Good evening. Now let's start talking about center of mass, and if you have forgotten to like, please like the video as well. And if you have not yet subscribed, subscribe to the Vedantu NEET English channel. Okay, do that. Thank you so much for doing it. See, if you have seen a person, imagine this particular person holding this rod and trying to walk over a rope. The concept involved over here is again of the center of mass. That person always tries to move that rod in such a way that the center of mass is always aligned with the rope, because think about it, if all the mass were to be concentrated somewhere here, then he will topple. If all the mass were concentrated here, then he will topple this way. But if all the mass is concentrated exactly where the rope is or just above it, then he will not topple. So center of mass is the place where you can assume all the mass is concentrated. So say for example, if I tell you, this is one object like this, there is one object maybe like this, there is one object maybe like this, then where the mass is concentrated, probably somewhere here, where the mass is concentrated, maybe somewhere here, maybe the mass is concentrated somewhere over here. All these are locations of the center of mass. COM. C stands for center, of, M stands for mass. So if you treat the object like a point body, that's where it should be located, so that you can assume that's where the center of mass is. That's where the mass is concentrated. It behaves like a point particle. Is that right? So if you ask me how do you locate the center of mass, it's very easy, guys. There was a very easy trick to locate where the center of mass is, what you do is, imagine you have a randomly shaped body. Imagine this is that randomly shaped body. I want to know where the center of mass is. What you do is you hang it in different ways. Let's say you hang it like this, and you find that the body goes like this probably. The body goes like this probably. Then 100% I know that the center of mass will be somewhere on this line. The center of mass will be somewhere on this line. Then probably you can hang it in some other weird way, maybe by tying a thread here. Okay, by tying a thread here, then you know the center of mass would be somewhere here. So this line would probably be here, and this line would probably be here, and the intersection point which is there, that is exactly that location of center of mass. You hang the body in 2 or 3 different ways. When you hang it, what happens is the center of mass will obviously lie below where you are hanging it. All the mass will try to come to the lowest position. All the mass will try to come at the lowest position. It will come below. So it will be somewhere on this line. Where is it on this line? I don't know. So that's why you hang it again in a different manner. So again the center of mass will be somewhere below where you have held it, where you have suspended it. So it will be somewhere here on this line. So hence the exact location will be where these 2 lines would intersect. So that is how you can locate the center of mass of any object. Is that right, everyone? Till this point clear? Shall we go ahead? So now, is there a formula? This is a practical way to locate center of mass. The answer is yes. There is a formula to locate the center of mass. So for that, I'll start with a 2-body system and I will give you some examples, and then you tell me where the center of mass should be. Say for example, I have a mass here of m, another mass over here of m. Then in the second case, this is small m. Then I have a huge point mass which is much larger than m, or it is just larger than small m. In these 2 scenarios, if you ask me where the center of mass is, because these 2 masses are equal, 100% the center of mass will be at the midpoint. It will be at the midpoint because the masses are equal. In this scenario, one mass is small, one mass is big. So if I have to see where the entire mass will be concentrated, I think it will be closer to the larger mass. So it is always going to be closer to the larger mass. It makes sense as well. It definitely makes sense. Similarly, if I tell you, listen, there are 3 equal masses on the vertices of a equilateral triangle. On the vertices of a equilateral triangle, 100% the center of mass will be at the centroid. The center of mass will be at the centroid, which is the center of that particular triangle. It will be at the centroid of the triangle, correct? So it is very easy if the diagram is symmetric, masses are equal, but if the masses are not equal, then it will obviously lie closer towards the heavier chunk of masses. For example, this is, say for example, this is like 0.5 kg, this is like 0.2 kg, this is like 0.7 kg, and then you have 2.5 kg over here, then you have over here 7 kg, and then maybe over here you have 3.7 kg, like that. Then if you see all these particles, the masses are heavily concentrated here, so probably the center of mass would lie closer to the heavier masses. I hope you can see that. So that is what you should understand first, that center of mass is located towards the heavier masses. It gets closer. That is a very important thing. So what's the formula going to look like? Here it is. So if you have the if you have to look at the one-dimensional formula, meaning the masses are arranged on a line, and let's say I call that line as my x-axis, then I will look at the 3-dimensional formula also. Imagine one of the masses is placed here, m1, another mass is placed here, m2, this coordinate is x1, this coordinate is x2, center of mass somewhere here, center of mass somewhere here. This is the x coordinate of the center of mass. First thing, the center of mass will lie between the line joining the masses. Between the line joining the masses. 100%. It doesn't make sense the center of mass will be here. How is it possible? Two masses are here, center of mass is here, or center of mass is here. So between these two only it will be somewhere lying. Correct? Does it make sense? Does it make sense, my dear students? So that coordinate is given by this formula. XCM, the x coordinate of the center of mass is, take the first mass, multiply it by its coordinate, take the next mass, multiply it by its coordinate, add it and divide it by the total mass. That's where the x coordinate of the center of mass is. Okay, let's take an example to make you understand. Let's take an example so that you guys understand this. Say we have a 2 kg mass here and it is separated by 6 meters, and then there is a 4 kg mass here. Question is, find the location of the center of mass. Question is to find the location of the center of mass. Where is it going to be? Here, I have not been given the coordinate system, like who is the origin, etc. So, let us choose our own coordinate system. It's not like, a hard and fast rule that, okay, this only has to be origin or that has to be only the origin. So, let's choose our own coordinate system. Nothing will go wrong, no matter what you choose. So, if I choose this as my origin, this being my y-axis, this will be the x-axis. Can you quickly think and tell me what will be the x coordinate of mass number 1? What will be the x coordinate of the mass number 1? That will be on the origin, so x1 will be 0. If I call this as mass number 2, what would be the x coordinate of mass number 2? It will be just 6 meters. Now the center of mass will be somewhere here. I don't know where it is, so let's assume the center of mass to be over here. So that x coordinate, using the formula m1 x1 plus m2 x2 divided by m1 plus m2. What is mass 1? Check it out. It is 2 kg. What is the x coordinate? It is 0 plus. What is mass 2? 4 kg. What is the x coordinate? 6. What is mass 1? 2. What is mass 2? 4. 2 into 0, 0. 6 4s are 24. 2 plus 4, 6. 24 by 6, 4 meters. So hence the answer is the center of mass is at 4 meters from which mass? 2 kg. So if it is 4 meters from 2 kg, how many meters will it be from 4 kg? This whole thing was 6, this is 4, this will be 2. So I can say also at 2 meters from the 4 kg mass. So that is the answer. Is that clear, everyone? Yep. Is that absolutely clear? Very good. Excellent. So this is how you use this formula of m1 x1 plus m2 x2 upon m1 plus m2 for locating the position of center of mass of any 2 point bodies. Now, the problem is generally you will not have 2 masses, you might have 3 masses. Sometimes these masses might not be, in a line, they might be arranged everywhere in space, basically 3 dimension. So what do we do then? So basically, in general, for multiple masses, in 3 dimension, the logic goes as follows. Say this is our x-axis, say this is y-axis and z-axis, something like that. And your masses are here, m1, m2, m3, m4, m5, m6, like that, mn, nth number of mass. The center of mass will be somewhere over here. This is where the center of mass is. So the x coordinate of center of mass, y coordinate of center of mass, and the z coordinate of center of mass is given by, instead of just m1 x1 plus m2 x2, the number of terms will be till n. So this will continue m3 x3 like that till mn xn, and it will not be just m1 plus m2, it will be m1 plus m2 plus m3 like that till mn. Same thing over here also, mass 1, but this will be in y coordinate, m1 y1 plus m2 y2 till mn yn, the whole thing divided by m1 plus m2 like that till mn. Same thing for z also, but since writing this takes a lot of time, generally the sum of many numbers is denoted by this symbol. This symbol is for summation. That means you are adding up. Whom are you adding? Mass into the z coordinate, because this is z axis coordinate, and this I stands for what is that variable number. Here that variable number is 1, 2, 3, 4 like that. So this will change from 1 to n. This will change from 1 to n. That's how you write it down. Same way at the bottom, you are adding up the masses. So this I will change. This is a variable. This will change from 1 to n. So this is a way of writing, in a simplified manner. Even this also I can write, this also I can write, but this is the same meaning. Summation symbol means whatever is there here, you just keep on changing that I value starting from 1, then 2, then 3, then till n, and you add them up. That is the meaning of it. So this is the correct formula, guys, for 3 dimension for multiple masses. For multiple masses. Keep that in mind. This is very, very important. For multiple masses. Shall we do a problem on this? Shall we do a question on this? Ready for it? Yep. Let's do. Here comes the question. So let's say we take the side of we take a square whose side is basically A, and let's say we have been also told that, listen, this is the x-axis, listen, this is the y-axis. Okay, so this is x, and that means this is origin, this is y-axis, and what you have done, you have placed few masses. One mass is here, another mass 2m is here, another mass 3m is here, another mass 4m is here, and the question says in this example that find where the center of mass is located. Find where the center of mass is located. So let's start by noting down what are the different coordinates of it. What are the different coordinates of each of these masses? Start from the first one. This guy is at the origin, so x is 0, y is also 0. If you look at this mass, x coordinate is 0, y coordinate is the side length, so it will be 0, a. This guy has x coordinate as a, y coordinate is also a, so a, a. This guy is located on the x-axis, so it is a, but y coordinate will be basically 0. So these are the coordinates. Now center of mass will be probably somewhere over here. Let's say it will be closer to the heavier masses. So let's say this is where the center of mass is. So the x coordinate of the center of mass will be, y coordinate of the center of mass will be, starting off with m1 is m, x1 is 0, plus m2 is 2m, x coordinate is again 0, plus m3 is 3m, multiplied by x coordinate is a, plus 4m, x coordinate is basically a. So just take x coordinates of each mass multiplied by the mass. Total mass will be m plus 2m plus 3m plus 4m. So what is it coming out to be? 0, 0. 3 plus 4 is 7ma. So 7ma, whole thing divided by 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So 10m. So hence the answer for the x coordinate will be 7 times a divided by 10. That is for the x coordinate of the center of mass. X coordinate of the center of mass is 7a by 10. Just check this out. Very good, Neha. Awesome. Yep. Okay. So somebody had asked any doubt. Krishna, I'm very good. Thank you so much. Yeah. Yep. So what about the y coordinate? Let's try to do it. So mass 1 and y coordinate. Mass is m, y coordinate is 0. Second mass y coordinate is a, so 2m multiplied by a. Third mass y coordinate is again a, so 3m multiplied by a. The last one y coordinate is 0, so 4m multiplied by 0. The whole thing divided by m plus 2m plus 3m plus 4m is equal to 0, 2ma, 3ma, this is 0, so 2 plus 3 is 5, so 5ma divided by 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, so 10m. So therefore, it is nothing but 5 by 10 is 2, so 1 by 2, so it will be a by 2. So that's the y coordinate of the center of mass. So final answer will be, the coordinates are 7a by 10, comma a by 2. That's the final location. 7a by 10, comma a by 2. Perfect. So this is how we use this particular formula. Let's use it in another place. This is going to be a very fun example. There is a seesaw, something like this. And that seesaw has some balancing point right over here. Okay. And it so happens that there is a champa, beautiful champa, sitting over here. Another beautiful champa sitting over here. And we have our Pandu, obviously our hero, sitting over here like this. Okay. So a Pandu is playing seesaw with two champas. Lucky Pandu over here. A Pandu is playing seesaw with two champas. And what is given to us is this seesaw joint is basically 2 meters from here. This is 2 meters. This is 2 meters. Okay. Pandu mass is not given, but champa's masses are given to me. This champa is having a mass of 30 kilos. This champa has a mass of, let's say, 50 kilos. So the question is, how much mass of Pandu is needed for this experiment to succeed, where they balance? Find the mass of Pandu to balance. So understand, Pandu is not choosing the girls. The girls are choosing the right Pandu who can balance and play with them the seesaw. Amazing, right? Yep. Okay. So let's see, guys, what should be the mass of Pandu? What is the crux of the problem? Can somebody think and tell me? Why is it even there in this chapter of center of mass? Let me tell you, the name of this chapter is center of mass, but the hidden name which Shreyas Sir has given, your captor has given, is it's a silent killer chapter. Meaning, you will not even know sometimes that, oh my God, it's a question of center of mass. Oh, I should have done it like this. So, it's a question of center of mass. Imagine you see such a thing, how will you solve it in the examination hall? The idea of this problem is, if somehow the Pandu plus Champas together, their center of mass lies over here. The center of mass lies over here. Then exactly at that point where the balancing happens, the fulcrum, the joint, the hinge, then the entire system will be balanced. Do you guys agree with this? Okay. Oh, Pandu likes the girls. See, Sukanya, the problem is Pandu might like the girls, but the girls should select the Pandu. No? If the mass is not correct, then imagine Champas fly up or Champas go down, they won't have fun. Champas like to balance. They don't want to go up, they don't want to go down, they want to balance. So they are going to select the Pandu. They will be like, next Pandu, please come in. What is your weight? Okay, if your weight is this, fine, you sit over here. How do they know how to calculate the weight? Because they attended my class of center of mass. Okay, so center of mass should be there. Let's choose some coordinate system. Where do you want the coordinates to be? Anywhere you can choose. Anywhere you can choose. How about choosing this only as the origin? This is my x-axis. So the center of mass, let's choose it at the origin. That will make the problem look little simpler, I feel. That will make the problem look little simpler. Oh, so that means in this situation, the x-coordinate of the center of mass is a big fat 0. The x-coordinate of the first champa, is basically 2 meters. The x-coordinate of the second champa, 2 plus 2, is basically 4 meters. The x-coordinate of our Pandu, is negative 2 meters. So let's apply our formula, guys. XCM will be m1 x1 plus m2 x2 plus m3 x3 whole thing divided by m1 plus m2 plus m3. But you know what the best part? The x coordinate is 0. So if the ratio is 0, the numerator will be 0. So this does not even matter. So therefore m1 x1 plus m2 x2 plus m3 x3 should be a big fat 0. Do you guys get it? Why? Because this is 0, that's why numerator is 0. So what is the mass of the first thing? First thing is 30 kg. So put 30 kg over here. The x coordinate is basically 2 meters. So put 2 over here. Second mass is 50 kg. So put 50 over here. What is the x coordinate? It is basically 4. Okay. Plus mass 3. That's what I need to find. Multiplied by the x coordinate, which is basically negative 2. So bring this over there. So I will get 2 times of m3 is equal to 30 into 2 is 60 plus 5 4s are 20. So this will become 200. So hence it will become 260 is nothing but 2 times of m3. So therefore m3 will be 130 kilos. 130 kilos. Got it, my dear students? 130 kilos. Now that's quite a lot of mass. So that will be like an uncle or some sumo wrestler or something. So I don't think these champas might like such a Pandu. So these champas will definitely be there for a disappointment over there. Yeah, 130 kilos. Definitely. Very, very huge Pandu. Not acceptable. So these champas will definitely be sad. Okay. So a very beautiful application of center of mass and how to find its location. Let's take another question. Very amazing question. Imagine there is a particle mass 1 of 2 kg at 3 I cap minus k cap meters. There is a mass number 2 of basically 3 kilos at 2 j cap plus 3 k cap meters, and there is a mass number 3 of 1 kilos at a location of I cap minus 2 j cap plus k cap meters. Question is, find the position vector of the center of mass. Find the position vector where the center of mass is located. Let's try to do this. Now, basically, this I cap, j cap is nothing but like the coordinates, guys. So you don't really have to think very differently. Just revisualize the formula. Instead of m1 x1, m1 y1, m1 z1 and all of that, why not just call it some position? So why not look at the position vector of center of mass as m1 r1 bar plus m2 r2 bar plus m3 r3 bar. This r bar is the position vector which includes all the three x, y and z coordinates upon the total mass, which is m1 plus m2 plus basically m3. So this makes our job easier rather than to find x, y and z separately. Yeah. So let's do this. All right. So mass number 1 is basically how much? It is 2 kgs. Okay. Multiplied by position vector, which is 3 I cap minus k cap. Mass number 2 is 3 kilos. The position vector is 2 j cap plus 3 k cap plus mass number 3 is 1 kg, and this is the position vector I cap minus 2 j cap plus k cap. The whole thing divided by total mass 2 plus 3 plus 1, which is going to be 6. Okay, we'll see that later. 2 3s are 6. So 6 I cap over here. Okay, 6 I cap over here. Then there is no I cap here. There is I cap here. So there is 1 I cap here. So 6 I cap and 1 I cap will make it basically 7 I cap. Okay. There is no j cap here. There is j cap here. 3 2s are 6. And there is minus 2 here. 6 minus 2 is 4. So plus 4 j cap right over here. 3 2s are 6. So 6 minus 2 is 4. Perfect. Then talking about k cap, you have minus 2 k cap here. Then 3 3s are 9. So 9 k cap here. So minus 2 plus 9 is plus 7. So plus 7 k cap. And there is one more k cap. So that makes it 8 k cap right over here. Is that right? So 2 plus 3, 5, 5 plus 1 is 6. That's it. That is the answer. That is the position vector of the center of mass. If you don't like it that way, no issues. You can write it also like this. 7 by 6 I cap plus 4 by 6 can be written down as 2 by 3 j cap plus 8 by 6 can be written down as 4 by 3 k cap meters. So that is the position vector of the center of mass. Is that okay, everyone? Loved the questions? Getting the concept of how to find the location of the center of mass for multiple masses or even three-dimensional question like in IJK form, or multiple masses in 1D, or in general like 2D objects also, like the square, triangle, all these things. So these are some of the nice examples that we have seen on how to use this particular equation. But there is a problem in this, and the problem is, imagine our mass is something like this. Continuous masses. Continuous masses. Continuous masses. Many masses are there. It is cross product? No, there is no cross product. It's just a simple sum. It's not a cross product. Okay, over here you might think that there is a cross product or anything. No, there is no cross product. It's simple vector addition. You are multiplying the mass with this number. So you are just multiplying it some number of times. So there is no dot product or cross product. Because this number is a scalar, this is a vector. Vector into a scalar is a vector. Is just multiplying it with that many times, 2 times, 3 times, 5 times, whatever it is. Is that okay, Rajesh? So it is not a dot product or a cross product. So when you have something like this, and imagine, let's say, this is our x-axis and I want to know where the center of mass is. Then I will divide this entire thing into small masses. Let's say one such small mass is over here, and let's say I call that as delta m. And that delta m will have some x coordinate, y coordinate, z coordinate, everything. So delta m has x coordinate of x. Maybe the center of mass of this will be somewhere over here. So the x coordinate of center of mass will be this kind of a body is called as a continuous body. Continuous body. The problem for such things is that how many masses will you write? M1, M2, M3, M4, M5, M6 like that. And there will be so many such point masses over here. So many. In fact, there will be infinite number of such point masses. I hope you understand that. Infinite number of such point masses. So if you actually write down this equation, it will be, mi, that mass is basically delta m and the x coordinate is x. You are summing it up upon delta m, but there are infinite such masses. There are infinite such masses. And each of this mass has to be very small, so it should be tending to 0 but not equal to 0. When such a thing happens, you do not use summation. You do not use summation when there are many terms to add and each thing is small thing. Then you call it as integration. Yes. So then you write it as integral of x into dm upon integral of just dm. That will just give you basically x coordinate of center of mass. Remember, integration is not just area under the curve. Integration is summing, is the sum of very small terms of very large in number. Very large in number. It's like 0.005 plus 0.00086 plus 0.0012 plus 0.00034 plus 0.00 this. So all small terms you add, but there are many such terms. That is what integration is at the end of the day. So therefore, I can then say, in general, for my x, y and z axis, where you have any random body like this, you basically take a small mass, you call it as your dm mass. The dm mass will have x coordinate, y coordinate, z coordinate. You can find the coordinate of the center of mass using this formula: xcm, ycm, zcm. The formula goes as follows: integration x coordinate with dm upon dm, integration y coordinate with dm upon dm, integration z coordinate with respect to dm upon integration again dm. That's the formula like. Okay. So for x, x will be there, for y, y will be there, for z, z will be there. As simple as that. Is that okay? Everyone? Till this point? Is that absolutely clear? Okay. Now, when you apply this integration, you might be wondering, sir, what are the limits? Well, the limits depend from case to case. Number one. We'll see a few problems so that you get a hang of it, an idea of it. Number one. Number two, you should know this trick of finding an element, and this is very critical. In fact, it is also there in electrostatics, which is a 12th standard chapter. And these element finding and writing is very, very crucial, which many teachers skip. So I'm not going to do that. Let's understand why we need to talk about elements. See, when I divide this big mass into small masses, dm, that dm can look like a small thin wafer like sheet. It can be like a volume, or it could be a thin line. So there are three different elements that we come up across in different geometries. One is basically a linear dimension. The second one is basically surface or aerial dimension, and the third one is basically volumetric element. So maybe imagine you have something like a rod like slender object, or maybe like an arc or something like that. Then when you take a small element over here or a small element over here, then the mass has to be written down in terms of something called as, let's write it down. You write it down in terms of like this: linear mass density. Linear mass density. The symbol for that is lambda, and it is measured in kgs per meter. If this has a width of dx, this has a mass of dm, then this lambda will be basically dm by dx, mass per unit length. The width of this element is dx, the length of it is dx. In that there will be a very small mass dm, so the mass per unit length is lambda. Everybody till this point clear? Absolutely. Linear mass density expressed in kgs per meter. So this is the first thing that you are learning. Similarly, imagine you have something like a disk or maybe like a sheet, something like a sheet. In that, somebody takes a small element like this over here. This is a sheet. This is basically like a sheet-like element. It's a two-dimensional object. You take a small element over here, you will have areal mass density. Symbol for that is sigma and unit will be kg per meter square. These symbols look very familiar to 12th standard and dropper students, because if you have studied electrostatics chapter, you would remember this as linear charge density. Instead of kg, it would be coulombs per meter. This you would remember it as sigma, which is charge per unit area. Unit would be coulombs per meter square of that sheet or that plate or whatever it is. So same terminologies, guys. So sigma will be, if that has a mass of dm, if that has an area of dA, so it will be dm by dA, as simple as that. Is that clear, everyone? So for sheet-like objects, you use dm by dA, not dx. The area of that will be a small area dA, not dx. See the units, it is meter square. This is meter, so that's why meter. This is area, so that's why meter square. Then imagine you have like a three-dimensional object, some three-dimensional object. In that, you are taking some volume. Okay, you are taking some volume. Here, what we use is volumetric density, volumetric or volume mass density or volumetric density, which is your normal density, which you have been seeing, the symbol for that being rho. Obviously, this is kg per meter cube. Like we know, the density of water is 1 gram per cc or 1000 kgs per meter cube. So it is your normal density, and that density will be the mass of that element, which will be dm, and the volume of that element, which will be dv. So that's it. Rho is the dm by dv. If it is a larger mass, if you are taking it for the entire length of the rod and the entire mass is counted, then it will be the total mass divided by total length. Then it can be written down as total mass divided by total length. If you are talking it for the entire sheet, then it will be the total mass of the sheet. It will be the total mass of the sheet upon the total area of the sheet. If you are talking about the total body, the stone, whatever the three-dimensional object is, the total mass would be m, the total volume will be v. If you talk for total thing, it will be total mass by total volume. If you are talking for the element, it will be dm by dv or dm by dA or dm by dx. Is that clear, everyone? Till this point, a very, very important concept of how to choose and what are the different types of elements. So let's learn how to use this integration related formula. Very rarely a question can come in NEET, but if it comes, my students should be able to do it. So let's try to do this question. Okay. So what happens is, there is a rod like this, and it so happens the density changes with different points. Here it is less dense, then the density keeps on increasing, and then you see that the density becomes too much over here. That's what happens. And it is given that, the length of the rod is basically L. This end has zero density. This has zero density. As you move and you choose some x point, at this particular x point, the density is given by 5x square, or let's say 3x square. This is the density, and unit will be obviously kg per meter. This is linear mass density. It is 3x square kg per meter. And the question is, find the location where the center of mass would be. So basically the density keeps changing. At x equals to 0, there is no density, it is negligible, and it keeps increasing because it's like an alloy, it's made of some different material, and it changes 3x square. If x is something, I know what is the density at that point. So let's see how to solve this particular question. First of all, tell me, will you use the concept of volumetric, aerial or linear? Quickly put it up in the chat box. Mass element wise, which concept will you use? Volume, aerial or linear? Think and tell me. Which concept will you use? Volume, aerial or linear? Yes, it has to be linear because it's a rod-like object. So definitely let's go to linear mass density. So when you do that, our element also should look like a thin element of a rod. Imagine somebody chooses an element like this over here. This is dm and the width of that is basically dx. If you ask me how that element looks like, probably it might look like this. It's a rod, right? So it's a part of a rod. So, oops. Probably looks like this. This is having a width of dx. This is basically having a width of dx. It might have an area of cross section as A also. That's okay, but that is not needed as of now. That's all right. A small cylinder-like thing. If I use the concept of lambda, linear mass density, this guy's mass is dm, so that lambda will be dm by dx. Not just that, okay? And this lambda is already given to be 3x square. This lambda is given to be 3x square. So 3x square will be dm by dx. That is what I understand just from this small element. I will just leave it over there. I will not do anything to it. Next, I will go to our formula of x coordinate of the center of mass. Integration x dm upon integration dm. Neither limits are there nor can I integrate it. You'll be like, sir, why can't you integrate? Guys, this is x, this is m. Don't say it is x square by 2 because x dx's integration is x square by 2. Either you replace x with m or you replace dm with dx. So you'll be like, sir, how do I do that? How can I just replace dm as dx? You can't. So you have to think, is there somewhere I can get a hint where I can get rid of dm and replace it with dx so that it becomes integrable? I look over here and then immediately you understand, yes, it was lying there all this while. In fact, if you see over here, our dm will be nothing but 3x square dx. So instead of dm, I have got a term in dx. So therefore, this integration will boil down to integration x divided by integration. So wherever dm is there, you replace it with 3x square dx. 3x square dx. Perfect. Now this number 3 will obviously come outside and it will also get cancelled. So let's just cancel that. It is not of any use for me. Let's just forget it. All right. What about the remaining things? So this will become integration of x square into x is x cube dx, and here I just have x square dx. Perfect. But the problem is, okay sir, now x and dx I can integrate, but what is the limit? What is the limit of integration? So that's where the length comes into play. That's where the length comes into play. See guys, our first element will be here, next will be here, next will be here, and it keeps proceeding till here. So it starts when the x coordinate is 0 and it ends when my x coordinate is the length of the rod. So hence the limits of this integration should be 0 to L, 0 to L. Oh, perfect. So what will happen now? X cube's integration is x raised to 4 divided by 4. Put these square brackets to signify it's a definite integration starting from 0 ending at L. X square's integration is x cube by 3. Limits of the integration 0 to L, of course, is equal to, first put L, then put 0. So L raised to 4 by 4 minus 0 raised to 4 by 4. Whole thing divided by, first put L. So L cube by 3 minus 0 cube by 3. Anything minus 0, anything minus 0, is that anything? So I am just left with L raised to 4 divided by 4. Here I have L cube and that 3 goes on the top. L cube cancels and I will be left with 3L divided by 4. So the center of mass will be somewhere here at a distance of 3 times L divided by 4, 3/4 of the length. Got it, everyone? How to do this question? So wherever some integration related question will come, right, you can just use this concept. That's all. Now, the best thing is, most of the times you don't even have to integrate because the integrations have already been done and you just have to remember the final result. That will come like a relief to you. Sir, thank God, for some problems or for most of the problems, you don't even have to integrate. Like, let me start off with simple examples. Imagine I tell you, you have a cylinder. Imagine you have a cylinder versus you have, a cuboid. You have a cuboid. Or let's say you have a sphere. Or you have a sphere. Or let's say you just have a square plate. Or let's say you have a simple rod. You have a simple rod. All these objects which I have drawn are basically objects which have some kind of symmetry. Symmetry means whatever is there on one side is there on the other side. Like our human body is also, from the outside at least, symmetric. If I have an eye on the right, there is an eye on the left. Ear on the right, ear on the left. Hands with 5 fingers, hands with 5 fingers. Leg. It's nicely symmetric. The nose also, whatever is there here is there here. So we have a symmetry of plane. So if you slice up the human body like this, you will see whatever is there on the right is there on the left. I know biology students will not like this because I know inside it is not the same. Yes, everybody, but at least from the outside it is same. But same way over here, there is some kind of symmetry. So you will see in such cases, the center of mass always lies on the symmetry of axis. Okay. So for example, this cylinder is obviously symmetrical here, but even whatever is there on the top is there below. So the center of mass 100% guys will be somewhere on this line. In fact, exactly at the midpoint of it. So that's where our center of mass would be. Here also, it will be inside this particular body. It's inside this, and that too at such a place where if you visualize some of these body diagonals, if you visualize some of these body diagonals, which go probably like this. So if you join the diagonals, wherever they meet, that is where it is. Here the center of mass is exactly at the midpoint. Here it is inside that sphere. That's where the center of mass is. Here the square plate, it is exactly at the geometrical center. So for symmetrical bodies, it is at the geometrical center. on the symmetry of axis, or basically the geometrical center or the geometrical center. Very, very important. Is this absolutely clear to everyone? Yeah. Great. This is one very important thing. By the way, some of students also have this notion, center of mass can't lie outside the body. Center of mass can't lie outside the body. I think that is also wrong, because if you imagine, everybody has had vada sambar. Everybody had vada sambar some time or the other. Imagine our vada looks like this. This is our beautiful vada which we will dip in the sambar later on. So where does the center of mass of that vada lie? The center of mass will be somewhere over here. So center of mass can lie outside the body also. Outside the body as well. In fact, forget vada. Imagine you just take a ring. Imagine you just take a simple ring. The ring is made of that metal or whatever it is only here. This point is in air. So this is where the center of mass is. It's outside the body. So definitely it can lie. Donut. Ranju Girish. Yes. The modern India knows about donut. Looks like, yeah, you have been watching a lot of Hollywood movies. Ranju. Yes, donut, or even for me it is vada sambar. Okay. All right. Great. So what if this geometrical center is not so easy to find? Like for example, let's start off by taking, can I just draw this over here? Yeah. This is like your cone. There is a small difference in both of them. This one is a solid cone. This one is a solid cone versus that is a hollow cone. Both of them do have axis of symmetry, meaning if you basically go from the top vertex to the center of the circular base, the center of mass will lie definitely somewhere on this line, because whatever is there here is there back, whatever is there here is there here. So that is like the line of symmetry, so it should lie somewhere on that, but whatever is there below isn't there on the top. So I don't know where exactly the center of mass would lie. So this is the example of basically a hollow cone. This is basically our solid cone. Examples of hollow cone, can somebody give me the examples of hollow cone? I think Krishna has already put that example, ice cream. Very good. So ice cream with just that waffle cone will be hollow, otherwise it would be solid. Thank you for reminding me to hydrate, Madhumati. Thank you so much. Birthday hat. Yes, Ranju Ghosh. Birthday cap. Birthday cap is a hollow cone. Solid cone also will be somebody put the cake inside the birthday hat as a prank, and then you ask the person to wear that birthday cap. Yes, that is what it is. Now please remember, hollow cone does not include the base which is there at the bottom, like the circular base. It's only the curved part of the cylinder. Now tell me, out of these two, if you tell me the center of mass is somewhere, center of mass is somewhere here, center of mass is somewhere here, in which case will the center of mass be closer to the base? In which situation should the center of mass be closer to the circular base? Think carefully. This is hollow, this is solid. This is hollow, this is solid. Sukanya, is it your birthday? Oh, you want that birthday cap with that cake, I believe. Yes. So, think this way. In the solid part, solid cone, more mass is there below because it's wider. So, it will pull the center of mass down. It is hollow over here. Fine, center of mass will be somewhere here. But in this case, there is more mass, more masala, more ice cream, more birthday cake below. So, it will definitely go below, down there. Is that right? So, center of mass should be lower in this case. And if you happen to measure how much this distance is versus this distance, this is more, this is going to be less. So, that distance from the base for this hollow cone comes out as h by 3. This has to be less than h by 3. So, it is h divided by 4. That's the location of it. Is it absolutely clear, everyone? All right. Oh, okay. Your name is Kanishka. Fine. Looks like you are from somebody else's account right now. Okay. So that is how you remember these formulas. If you ever get confused, hollow cone, was it h by 3 or h by 4? Think hollow is empty. Solid, more mass will be pulled down. It's full of that masala. So it is going to pull it down. So that distance from the base will be less. So this is less. Obviously h you divided into 4 parts versus h you divided into 3 parts only. So h by 3 will be more, h by 4 will be a smaller part. So that's why this is less, closer to the base. Same way, I can also, do this for hollow hemisphere. Now, a sphere is a complete sphere, just like your ball or just like this earth or this globe over here. Somebody breaks it, northern, southern hemisphere. So that's a half of a sphere. So that's why hemisphere. Hollow means inside it is empty, like a bowl. The bowl in which you put some gravy or some sambar. So that bowl is like your hollow hemisphere. Nothing is there in it. You fill sambar in it. So then it will become nothing but a solid hemisphere. Then it will become basically a solid hemisphere. So this is solid now. Again, the same story repeats. There is definitely an axis of symmetry. It goes from the top till the bottom center, the circular center. The center of mass will be probably somewhere here. Here in this case it will be here. If you ask me, in which case the center of mass will be closer to the base, is just like the cone, just that this was a flat surface, this is a curved surface. So the center of mass will be closer to the base when it is solid versus when it is hollow. So this is the case of solid hemisphere. So this over here is basically r by 2. Okay, this is basically r by 2. And for the other one, for solid, anybody remembers what is it? Anybody remembers what it is? Well, it is nothing but 3r by 8. It is nothing but 3r by 8. 3r by 8 is slightly less than r by 2. R by 2 is half, exactly at the midpoint. This one is 3r by 8, meaning, if it was 4r by 8, it would be half. 3r by 8 makes it slightly less than half, closer to the base. Okay, no, it's not r by 3, it is 3r by 8. Yep. Very good. Cool. Keep these things in mind. Now, how can you use these examples? We'll come to that as well. But, yep, 1 second. Let me show you some beautiful application of this. Imagine somebody tells you that there is a cone like this, whose mass is given to be 4 kg, height is given to be, let's say, 8 meters, and radius is given to be 50 centimeters. If this is considered as the ground level, find the gravitational potential energy. Find the gravitational potential energy. That's the question. Now you will be like, what the hell? How did gravitational potential energy even come over here? So the idea is, observe carefully. Like I said, what is the second name of center of mass chapter? Silent killer. Who gave this name? Captain Shreyas Sir. Why? Because you will not know, only suddenly center of mass concept will come. So in this case also center of mass concept is there. Why? Because each mass is at a different height from the ground. This is closer, this is far away, this is far away, this is close, this is close. So guys, every mass is at a different location. So you assume the entire cone to be a point mass. So now to locate the potential energy, I need to know where the center of mass is from the ground. So this is that h. So our gravitational potential energy will be mass of the body g and h. This is the height. This is basically the height of the center of mass. But I don't know that height. Instead, what I know is this. I know this distance d I know. And how much is that d? I just told you, if it is a solid cone, let's say this is solid cone. Let's assume this, or else things will go crazy. Okay, let's say it is a solid cone. For solid cone, it is h by 4 from the circular base. So hence that d from the circular base, which is h by 4, will be, height is 8 by 4, it means it is 2 meters. So can you quickly think and tell me how much will h be? Guys, the total height of the the cone is 8. From that you subtract this 2. So shouldn't it be 6 meters? Everyone? Understood? So now we can solve the problem. What is the mass? Mass is 4 kg. What is acceleration due to gravity? It is 10. What is the height of the center of mass? It is 6. 6 4s are 24. Into 10 will make it 240. So that's how you find the gravitational potential energy. So simple, easy peasy. Got it, everyone? Everybody got it? Understood? Oh, clear? Oh? Awesomeness. Let's do this. Next question coming up on your screen. Another question, guys, coming up on your screen. In this question, what happens is, there is a table. And what happened is, there was a chain, or let's say some snake, which was hanging like this. So this snake was hanging like this. This snake is slippery. It starts falling down, and eventually the entire of the snake is falling down like this. So let's say 1/3 of this chain, this rope, this snake, 1/3 is hanging and let go. Okay, as shown. Question is, find the speed when you know it's vertically falling down as shown. That is the question. It is completely down and it is falling down. Okay, very nice question. Then you will be like, sir, why is center of mass coming over here? Don't worry, you will see why. One thing I know, that whenever I have to find out gravitational potential energy of a big body, I'll just see where the center of mass is and my job is done. Okay. Now, if you just look at this question, it immediately should click you that it is not a question really of Newton's laws. Rather, it is a question of energy conservation principle. Why? Here, the snake was on the top. Here, the snake starts falling down, it loses gravitational potential energy. So, the gravitational energy loss is converted into the gain of kinetic energy. And that's the reason why this guy has some speed. Oh, so I have to use energy conservation. Friction is not there, snake is slippery, nicely it will slip. If you have held a snake, you would know that. I mean, you don't even have to hold a snake to know that. You know that by imagination that they are very creepy. Isn't that Krishna? Krishna has already put a snake for all of us. Thank you, Krishna. All right. Great. So, my dear students, let's start by assuming some ground level as zero potential energy. So, this is my zero reference potential energy. Nothing on this line will have any energy. So, if you see this much mass over here, it has 0 joules of potential energy. Nothing it has. This will definitely have. There is nothing on the top. This will also have. Look at where the center of mass is. The center of mass will be here. And this distance obviously will be L divided by 2. I hope you guys agree with this part. The center of mass will definitely be at half the length. It's a rod-like thing. It's a linear thing. So it will be at L by 2. So think carefully. What should be the potential energy? Bidu, PU College, Baswanna, let me know your doubt. You can put it up. Yep. So think about it. What will be the potential energy in this case? The potential energy, gravitational potential energy in the final situation will be M, the total mass of the snake. Let's assume it to be M. G as G. What is the height? It is negative L by 2. Why negative? It is below the line. If it was above, you would put it as mgh. So naturally, if it is below, it should be negative. So hence the answer will be minus mgl divided by 2. Is this absolutely clear, everyone? Exactly. Obviously, the snake has some kinetic energy as well, which is what gives it that speed, which we do not know yet. That is what we have to find the speed. Right now over here, this entire snake was at rest. Okay. This part has no potential energy. But what about this part? I think this part does have. But for that part, where is the center of mass located? It's here. Can somebody tell me how much is this? Because this is where our center of mass is. This is exactly where our center of mass is going to be. This whole thing over here, 1/3 of it, that means it should be L by 3. So it will be half of that, that means half of L by 3, which will make it L by 6. Is it not true? This will be L by 6. Lot of people write it as L by 3 and make a mistake over there. Is this point clear? Is this point clear, everyone? This is the snake chain or rope hanging problem, which is let go and it falls down finding the speed. These kind of questions are very common. Now to find out the potential energy initially, what will I do? Mass is mass, G is G, height will be, do not forget, negative, so minus L by 6. But I'll tell you something, there is a problem in this equation. This is not correct. It is not minus mg L by 6. Can somebody point out to the mistake? There is something wrong in this. Be careful. I am referring to this part. This part does not have mass m. It's 1/3 of the rope or the snake. So the mass will be, what will it be? It will be m by 3 because 1/3 is hanging. So this is the second place where many people make a mistake. Yeah. So Shivashish, you can join the Telegram channel. The link is there. Also the, our treasure box. So when you're watching this video, just make sure you're a part of our Telegram channel, or the WhatsApp community is also there. See, this treasure box is there. This treasure box is there. And our Telegram channel is also there. So if you go to the treasure box right over here, you can see all the chapters are there. Biology, chemistry, physics, PYQs, everything. Class wise arranged, subject wise arranged with the notes, everything is there. Okay. I hope this is clear. Yes. So this is the mistake which many students do, like I said. So it will be minus mgl 3 6 18. That's it. Our job is done. So now we'll say conserve energy, and initial kinetic energy plus initial potential energy will be final kinetic energy plus final potential energy. Initially it was at rest, so no kinetic energy. Initially gravitational potential energy will be minus mgl divided by 18 is equal to, finally it will be half mv square. Potential energy will be negative mgl divided by 2. Now obviously mass and mass gets cancelled. Okay, let me shift, or let me keep half mv square as it is. Let's shift this over here. So gl divided by 2 is equal to, minus gl divided by 18 is equal to, m has got cancelled, so v square divided by 2. Okay, so LCM of this is basically 18. So, it will become 9 times. So GL is also common. So 9 minus 1 divided by 18 is equal to V square divided by 2. So what happens next? This 2 cancels with this 9 times. 9 minus 1 is basically 8. So therefore, our V squared becomes 8 times GL divided by 9, or V will become root of 8 GL divided by 9, or V will become, root 8 is 2 root 2, so 2 root 2 GL, and root of 9 is basically 3. So 2 by 3 root 2 GL. That is the final answer. Got it, everyone? So this is how you use the concept of center of mass. Let's do a quick recap. Whenever hanging problems come, a rope is hanging, always remember when the work done, speed, etc. is asked, it's usually a concept of center of mass. So this part and this part will have their different locations of center of mass. The center of mass would have shifted. That is the reason why gravitational energy would have changed, and that is why kinetic energy would have also been gained or lost. So you take some tabletop as the zero line. Based on that zero line, you measure the energies. Because all the masses are below, you should expect the energies also should be negative. If it was on the top, obviously it would be positive. This part on the table will be having 0. This part hanging will be negative. For this part, the total length was L, center of mass at L by 2. So it will be mg, center of mass location is L by 2, but with a negative sign. For this part, the mass itself is 1/3 because 1/3 is hanging. G is G. The center of mass will be half of L by 3. Half of L by 3 is L by 6. So you put L by 6 but with a negative sign. Rest is energy conservation. Initial kinetic energy was 0. Initial potential energy was this guy. Final kinetic energy is half mv square. Final potential energy is minus mgl by 2. Solving it, you will get the answer. Is this now properly understood, guys? Okay, amazing explanation. Thank you, Krishna. I'm so glad everybody understood this. So these are some amazing applications of center of mass, and you saw how or why you should know these things as well. Anywhere and anyhow you might be asked these things. Let's take one more example maybe. Let's take one more example. Okay, the question is, if the radius of the bowl is 16 centimeters, find the location of the center of mass from the base. From the base. That's the question. Come on guys, think about it. If the radius of the bowl is 16 centimeters, can you find the location of the center of mass from the base? From the base or from the ground basically. From the ground surface. One and the same thing. This is your ground. Come on, think carefully. Think carefully. Center of mass will be somewhere over here. And usually we would know this distance. That distance I can call it as D. That distance, first figure out whether it is hollow or whether it is solid. Whenever it is a ball, it is hollow. Nothing will be there inside of it. Only when you put some liquid, something you fill it with, then it will become solid. So right now it is hollow. So for a hollow, it is just R by 2 guys. So for hollow, it is just basically R by 2. So hence, using that formula, it will be 16 by 2, which is basically 8 centimeters. So naturally then, this distance, height from the base will be total thing, which will be the radius minus this D. So it will be 16 minus 8, which is basically again 8 centimeters. So that's the answer. It will be at a distance of 8 centimeters from the ground level. Is that understood everyone? Don't use 3R by 8. Why? Because it is a bowl. Bowl means hollow. Visualize, normal bowl. It's going to be hollow. Only when it is filled with water or it is filled with something, then it will be a solid thing. Yes, that's the answer. Now there are some more geometries which you might have to remember. One of those geometries is an arc, a bent wire basically, an arc, and the second geometry is basically a slice of a circle, which is also called as the sector. First things first, the center of mass for such geometries will lie on the line of symmetry. Here you need to be little bit careful because it's an arc. You first imagine the circle, the center, and then draw the line of symmetry. The line of symmetry will be something like this. This angle is usually given to you. This complete angle, that complete angle will be theta, the radius will be r, this radius will be r, this complete angle obviously will be theta. The center of mass, right, will be somewhere here. Here the center of mass will be somewhere here. And usually the distances of the center of mass are measured from the center. They are measured from the center of the circle which the sector or the arc is a part of. The difference between an arc and a sector. Everybody has eaten a pizza. Yes, you order Domino's pizza, you get slices. Each slice is a sector. Some of you like the cheese, you don't like the outer part, the crust. So you eat that cheesy part, the toppings part, and you give the crust to a friend who likes crispy fries and crispy fried items. So that is that arc. Got it, my dear students? That's the difference. Arc is like a bent wire. It's like a linear object which is bent. Sector is a two-dimensional object. Think of it like that. Okay. So tell me, in this case versus this case, which one will be more, which one will be less? For arc and sector, will the center of mass will be far away from the center or will it be close to the center? What do you think? Think about it. If it's an arc, the mass is only there on the outer edges. So center of mass will be close to that. Nothing is there here. Whereas in the case of sector, masses are not just there here, it is also there here, everywhere. So it will come little bit closer to the center. That's the difference. So this should be less, this should be more. This distance is radius into sine theta by 2, whole thing divided by theta by 2. Here also the formula is same, r sine theta by 2 by theta by 2. But since this is less as compared to this, remember this number which will multiply it will be also lesser than 1. So it will make it smaller. 2/3. So if this is 1, 2/3 is this. So if this is 1 unit, this will be 0.667. So, it is 2/3 of this distance. So it will make it smaller. So the formula otherwise is very, very similar. Same, but different. Okay. This is something which you should definitely remember. The last geometry which you might need is that of a triangle. But this is a triangular sheet. This is a triangular sheet. This is a triangular sheet. Don't think of it like point masses. No, even this is a mass, all these are masses only. So in that case, the center of mass, any triangle, not just equilateral, it can be isosceles, right angle, scalene, anything. The center of mass is at the centroid. Where is it going to be? At the centroid. So you will be like, sir, how do I find the centroid? The position of the centroid is given by, if you just know the coordinates of the vertices. If you just know the coordinates of the vertices, this is first vertex, second vertex and third vertex. Just add them, x1, x2, x3 and just divide it by the number 3. Y coordinate will be y1 plus y2 plus y3 divided by 3. That's how simple it is to find the centroid of any random triangle. Yep. So keep this in mind. Everyone? Cool? Yes, the sector was lesser than the arc and this is for a triangular sheet. All these are again very, very crucial. So let's see some examples on this. Imagine this is your xy coordinates. Okay, this is a right angle triangle and the question is find the location of the center of mass. This is a triangular sheet, lamina. Lamina means a two-dimensional object which is basically like a sheet-like object. Question is find the location of the center of mass. I just have told you the center of mass will definitely lie on the centroid. The center of mass will definitely lie on the centroid and the best way to find the centroid is just take the coordinates and divide it by 3 after addition. x1 plus x2 plus x3 whole thing divided by 3. That is the manner in which you can find the location of the centroid. So obviously it will have some y coordinate, it will definitely have some x coordinate, but before that, what are the coordinates of the vertices? This is obviously 0, 0. This will be obviously 5, 0. This will be obviously 0, 3. Everyone fine till this point? So let's find out what is the x coordinate of the center of mass. and also what is the y coordinate of the center of mass. For the first one, just take x1 plus x2 plus x3 divided by 3. This is y1 plus y2 plus y3, whole thing divided by 3. What is x1? It is 0. What is x2? It is also 0. What is x3? That is basically 5, whole thing divided by 3. So this will be just 5 by 3 units. Here, y coordinate 0. Next y coordinate is 3. Last y coordinate is basically 0. Whole thing divided by 3. So basically the answer is 1 meter. That's it. So finally, the location of the center of mass will have the coordinates. X coordinate will be 5 by 3 meters and y coordinate will be 1 meter. That's it. Understood, guys? We are not doing integration anywhere. We are just doing, simple formula application. That is why I said these formulas are very, very super duper critical. Let's do for this and this also. Let's do for both of them. Okay, let's see the application of both of them. Imagine there is a semicircular disc versus semicircular arc. Semicircular wire, and this is semicircular disc. This is also having the same radius. Where would the center of mass lie? Where would the center of mass lie? First things first, it should lie on the line of symmetry. So this is the line of symmetry here. This is the line of symmetry here. 100% the center of mass will lie somewhere over here versus somewhere over here. Always the distances are measured from the center. Distances are measured from the center. Okay, fair enough. So next thing, I know for the formula for an arc, the distance from the center is r sine theta by 2 by theta by 2. Correct? That was the formula. R is r. What is theta? Can you think and tell me what is theta? Theta is this entire angle. Theta is this basically entire angle. Don't call it 180 degrees. Rather say that particular theta is pi radian. Always theta is in radian. So it is pi radian. So it is basically pi by 2 and this also is pi. So be very careful. If you put answers in degrees, you will get it completely wrong. So never ever use degrees, always use radians. So sine 90, this is pi by 2 which is 90, which is 1 upon pi by 2. So 2 goes on the top, so 2r by pi. That is the answer from the center. Is that clear, everyone? Okay. What about this? Again, use the same formula, but there is that number 2/3 r sine dash by 2 dash by 2. What is that dash? This whole angle. How much is it? Pi. So put pi over here, put pi over here. That's it. So it will be 2 by 3 into r sine 90 is 1. This pi is there below. This will go on the top 2. 2 2s are 4. 4r by 3 pi. So you can get this, any formula if you remember the God formula. The God formula is this one. God formula is this one. I can show you one more problem which will convince you why you should remember this formula. Imagine the question goes like this. It's a quarter circle. Imagine it's a quarter of a disc. Imagine it to be a quarter of a disc of some radius r. And the question is, find where the center of mass is going to be located. Now you might be wondering, sir, how do I do this problem? I don't know this formula for quarter of a circle. Then I will remind you, see, listen, you don't have to remember quarter of a circle formula. If you remember sector or arc, you can do it for any angle. So that's it. Theta will change. So remember the God formula. That's it. So because this is like a solid thing, I feel we should be using the distance of the center of mass is 2/3 r sine theta by 2 by theta by 2, because this is exactly for a sector. Now you might be wondering, sir, what is the angle of the sector? Well, it's right over here. It should be pi by 2. It should be pi by 2. And do not forget, the center of mass will lie on the axis of symmetry. So it should be somewhere over here. It should be somewhere over here. This is where the center of mass is, and this is what we are trying to find. Okay. So this will be 2 by 3. R is R. Sine of 90 by 2, which is pi by 4, upon pi by 4. Did you understand why it became pi by 4? Theta itself was 90. So 90 by 2 is 45. 45 is pi by 4. Perfect. So this will become 2 by 3 r. Sine of 45 degrees is 1 by root 2. Pi goes below. 4 goes on the top. So it will become 8r by 3 root 2 pi. That is what that distance will be from the center. That is from the origin. That is your D. But usually you will be asked coordinates. So what will you do? Because you are asked coordinates, I want to find this. I want to find this. How do I find x coordinate or the y coordinate? Let me tell you, this particular angle will be 45 degrees because it bisects, right? So wouldn't this be d cos 45, which is basically d by root 2? And wouldn't this be actually d sine 45, which is d by root 2 again, which means both the coordinates are the same. So xcm will be the same as ycm, which is d by root 2, which is 1 by root 2 times of this distance, whatever we found, 8r by 3 root 2 pi. What happens next? Root 2 becomes 2. 2 goes with 8 becomes 4. So hence the coordinates just become 4r by 3 pi. 4r by 3 pi. So therefore the center of mass coordinates are 4r by 3 pi, comma 4r by 3 pi. Both the coordinates were the same. Is that clear, everyone? Did you love this question? Did you understand this question of how to use the concept of center of mass for sector or for an arc? Cool. So that's why all these formulas are very important, and I have tried to do as many models of questions which can be possibly asked in your NEET examination. Anything beyond this will not be asked. Okay. So you should know these sure short models. Anything else will be a combination of these models. Let's go ahead. Now that we have learned all these models for solid geometry, sector, hemisphere, cone, hollow, triangle, etc. The next part of this chapter starts with what happens when the center of mass is in motion. So if the particles of a system, move, then the center of mass may be in motion. Then the center of mass may be in some kind of motion. And we can find that out. It is not that difficult. Say there is a mass 1 moving with some velocity. It has some acceleration. Some another mass moving here having some another acceleration. Some mass here moving like this having some another acceleration. Like that, many masses will be there. And finally, we have the nth velocity and the nth acceleration. Just like we used to say, hey, listen, the center of mass has a position given by m1 R1 plus M2 R2 till Mn Rn, whole thing divided by the total mass. Same way, the velocity of the center of mass is given by m1 v1 plus m2 v2. These are all vectors, please mind it. Mn vn, whole thing divided by the total mass. As simple as that. And the acceleration of the center of mass is given by m1 a1 plus m2 a2, like that till mn an, the whole thing divided by m1 plus m2 plus mn. Very, very important formulas again. So this is for the position, this is for the velocity, and this is obviously for the acceleration of the center of mass. So center of mass can definitely have some velocity, it can definitely have some acceleration. Cool? Very similar looking, nothing new to by heart. Nothing new to by heart. Yes, Madurai. Thank you, Krishna. Hi, Evening Star. All right. So let's do some questions on these applications. Let's do some questions on these applications. Let's start. Imagine it is given to you. Pandu of mass 40 kg runs away from Champa, whose mass is, oh my god, that's higher mass Champa, at a speed of 3 meters per second, while Champa moves at 4 meters per second. Find the velocity of center of mass. The question is, find the velocity of center of mass. Let's visualize this. It will be much easier for us. So imagine this is our Pandu, whose mass is 40 kg, and this Pandu is running away from Champa. I don't know why. And Pandu's speed is 3 meters per second. Champa is also angry with Pandu. Her mass is 60 kg and she is running with a speed of 4 meters per second. Okay, fair enough. Question is center of mass. Yep. Velocity. So center of mass will be somewhere over here. I don't know where it will go. So what I will do, first of all, let's assume some positive direction and some negative direction. Let's take this as the positive axis, positive x-axis, okay? So always assume some direction, that's all. So velocity of center of mass, there are two masses, so m1 v1 plus m2 v2, whole thing divided by m1 plus m2. What is the first mass, guys? Pandu's mass. How much mass is it? 40 kilos. Okay, 40 kilos. What is the velocity? It's 3, but don't put it as 3, it will be minus 3. Why? It is on the negative side of the x-axis. As simple as that. It's opposite to the positive that we have assumed. So that's why minus 3. Mass 2 is of Champa, velocity 4. Whole thing divided by total mass, so 40 plus 60. 40 plus 60, that's all. 4 3s are 12, so this will be minus 120 plus 6 4s are 24, so 240. Whole thing divided by 100. So 240 minus 120 will be 120 divided by 12. So that will be 12. Is that correct or wrong? I think something went wrong. Oh, I know what went wrong. It was 100. It can't be 12, so 60. This was 100. So yes, this was 120 by 100. So it would be 1.2 meters per second. Yes, 1.2 meters per second. Now, the moment you get 1.2, which direction is it? Is it towards the right or is it towards the left? Can you put it up in the chat box? Yes, which side will it be? Power of regular exercise is 130 kg. Oh, this Pandu would be probably suitable for those champas. I think this Pandu is running towards those champas. I think that's why this champa got angry. Remember our first two champas at the starting stage only? That Pandu was very heavy. I think this Pandu is meeting these two champas. This Pandu was quite heavy. We got it as 130 kg. Oh, okay. So guys, yep. Which side will it go? What do you think? Yes, it will be towards the right side. So, center of mass goes with a speed of 1.2 meters per second towards champa. Towards champa in this case. Is that okay, everyone? As clear as water? As clear as Sprite? Very good. Let's do another question. Let's do another question. If mass 1 of 2 kg accelerates at 3 meters per second square towards the north, mass number 2 of 3 kg accelerates at 1 meter per second square towards the west, mass number 3 of 1 kg accelerates at 4 meters per second square towards the east, the acceleration of the center of mass will be. The acceleration of the center of mass will be in which direction, what is the magnitude, all of these things. So let's try to do this. Let's visualize this first. Let's draw the directions. This is north, this is east, this is west, this is south. This is positive, this is also positive axis. Okay. Mass number 1 going towards the north. So we have one mass going like this with 3 meters per second square. Mass is 2 kg. This mass number 2 is going towards the west. This mass is 3 kg and acceleration is 1 meter per second square. Last mass 1 kg is going like this. This is 1 kg with an acceleration of 4 meters per second square. So, best way to do this, acceleration of the center of mass. Do it in vector form. It will be easier because it's a two-dimensional problem. So, whenever it is 2D or 3D, I think it is better to solve it via vectors or components. Okay, let's think about it. What is mass number 1? Mass 1 is 2 kg. Okay, acceleration is 3 j cap. So acceleration is basically 3 j cap. I am doing it in ij because it will be easier. Mass number 2 is 3 kg. 3 kg is going towards negative I cap direction with 1 meter per second square. So minus 1 I cap. Okay. Plus mass number 3. What is mass number 3? It is 1 kg. Acceleration is 4 in the I cap direction. So 4 I cap. Whole thing divided by mass 1, 2, mass 2, 3, mass 3, 1. Okay. So I cap wise, this is 4 I cap, this is minus 3 I cap. 4 minus 3 is just 1, so 1 I cap. 2 plus 3 is basically 6 j cap. And 2 plus 3, 5, 5 plus 1 is basically 6. Hence, it will be 1 by 6 I cap plus j cap meters per second square. So, if you look at the x component, it is hardly 1/6. So 1 by 6 I cap. And this is basically complete 1 unit. This is basically complete 1 unit. So this is j cap. So our total acceleration will be like this. So this is how our center of mass will accelerate. Is that clear? Everyone understood? Thank you. I'm so glad you are able to understand every single thing. Let's do the next question coming up on your screen. So we did this problem using vectors because it was a 2D problem. This we didn't do because it was not a two-dimensional problem. Next example. If m mass has a velocity of 2v towards the right, then find the mass which is moving like this with a velocity v, then, or basically 3v, such that the center of mass is going to be at rest. Such that the center of mass is going to be at rest. Let's try to solve this question. The center of mass has to be at rest means the velocity of the center of mass should be basically 0. Okay. This mass going this side, this mass going this side. So using our formula, VCM is equal to m1 v1 plus m2 v2 divided by m1 plus m2. Best part, VCM only is 0 because it is given in the question. I am not saying, it's given. Okay. What is mass 1? It is m. What is velocity 1? It is 2v. Okay. What is mass number 2? I don't know that. What is velocity 2? It is 3v but opposite side. Why negative? Because always you choose one direction as positive and obviously the other direction will become the negative direction. So all the right hand side velocities will be positive, left hand side velocities will be negative. And this whole thing divided by mass 1 plus mass number 2. Anyways, the ratio is 0, so numerator should be 0. So therefore 2mv minus 3m2v will be 0. v will cancel, so 2m, take it on the other side, will become 3 times of m2. Therefore, mass number 2 will become 2 by 3 times of m. So that's the answer. If this mass is 2/3 of this mass, center of mass won't move. The center of mass won't move. As simple as that. Cool. Let's go to the next question, guys, coming up on your screen. Here it comes. Here it comes. Imagine there is a pulley which is hung from the ceiling. This pulley has a thread wrapped around it. There is a small mass over here, another mass over here. Let's say this mass is m, let's say this mass is 3m. You leave this system, these two blocks which are there, their center of mass will be somewhere over here. Center of mass will be somewhere over here. The question is, find the acceleration of the center of mass. Find the acceleration of the center of mass. Very nice question. Now what I have seen many students do, sir, one mass will go up, other mass will come down. If this goes x units, this will also go x units. If this has some acceleration, this will also have the same acceleration. Sir, both accelerations are opposite, sir. Same value, sir. So they will cancel. No. Lot of people think acceleration should be 0 for the center of mass, but that is not correct. Why? Even though they are moving the same amount, don't forget the fact the higher mass is going down, the lighter mass is going up. This mass will have lower contribution in the center of mass. This guy's acceleration will have more weightage in the center of mass. So center of mass must move definitely down. Do you guys agree with this statement? Do you guys agree with this statement? Why the center of mass must move definitely down? Okay? Even though they have same magnitudes, the masses are different. So the heavier mass will have more say. Like your elder brother or some elder cousin in some maybe game that you are playing. Whatever he says has more weightage. If he says while playing cricket, you are out, means you are out. If he says that this is a goal, that means it is a goal. If he says that this is how that UNO game is played, means that is how the UNO game is played. They have more say. Sometimes you will say something and then the elder brother will listen, but that is very less. That is how it is. Correct? Okay. So let's first of all write down how much is this guy's and this guy's acceleration going to be. How much is this guy's and this guy's acceleration going to be? This is A2. Let's say this is A1. We know A1 is equal to A2, and that is basically the difference of the masses upon the sum of the masses multiplied by G. You will be like, sir, where did this come from? Newton's laws. That's why older chapters are necessary. You will be like, sir, can I do this chapters? Can I do these questions without center of mass? Some of them, yes. Some problems will need. That's why chapters are linked. And that's why you should go in a sequence. Okay. So, difference of the mass m2 minus m1, which is 3m minus m, upon m1 plus m2, that means m plus 3m into g. So, that will be 2m divided by 4m into g. mm cancels, 2 by 4 is half, so it will be g by 2. So, it will be basically g by 2, which is, okay, 5, we can put it later on. Coming back to the acceleration part, let me choose the downward direction as positive because I know things will be positively there downwards. So that will be easier for me to solve. So using the formula, A center of mass is m1a1 plus m2a2 divided by m1 plus m2. What is mass 1? Mass 1 is m. Acceleration is up, so it will be negative. So it will be minus g by 2. Remember, these were just the magnitudes. So although I might say this is a1 and a2, so it is actually magnitude of acceleration and magnitude of the second guy's acceleration is g by 2. So this negative sign comes because of our sign convention, nothing else. Okay. Plus mass number 2, 3m. Acceleration is down, so it will be positive. So it is plus g by 2 upon m plus 3m. So how much will this be? So this is 3 mg by 2 minus mg by 2, 3 by 2 minus half. So think of it like this, it is 3 by 2 minus half, whole thing divided by, this is 4m. 3 minus 1 is 2, so it will become mg into 2 by 2 divided by 4m. 2 by 2 is 1, mm cancels, so I think the answer should be g by 4, which is also 10 by 4, which is also 2.5 meters per second square downwards. Had I chosen upwards as positive, the answer would have come out to be negative, which would still mean the acceleration of the center of mass is down. This meaning will not change irrespective of whether you choose downwards as positive or upwards as positive. Got it? Yep. Mimels Dairy, just DC Pandey problems? Definitely not. Please do in-text questions and some of the NCERT questions, in-text and NCERT. Number 1, your any problem solving book definitely needed. Third important thing is basically your PYQs. PYQs have to be solved. You can't do away with PYQs. In fact, I'm going to talk about a very interesting book which I have been recently following, and I found this book really good. It's only problems. Okay, it's got only problems and problems and problems. It's got everything, and this is first time which is a NCERT based question book, because NTA picks up questions from NCERT. It's a complete NCERT problem solving book. Each chapter has so many questions along with the PYQs. So I will talk about this book separately. This is NCERT Tejas. I will show you a demo of it very soon. Okay? Yes. So that is how you solve this particular question. So we have done this. All right. Now, there is also one important thing which you should know over here. What about the momentum of the center of mass? What about the momentum of the center of mass? So observe this carefully. VCM was m1 v1 like that till mn vn whole thing divided by m1 plus m2 like that till mn vn. Shift this guy over here, so it will become m1 plus like that till mn, and this is VCM is equal to m1 v1 plus dot 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 till mn vn. What is this? This is the total mass of that particular system into VCM. is equal to, what is m1 v1? It is nothing but momentum of object 1. m2 v2 momentum of object 2. This is nothing but momentum of the nth object. So what is this term? Total mass into center of mass velocity is nothing but the momentum of the center of mass is equal to, what is this? This is basically the total sum of the momentums. So P1 plus P2 like that till Pn. This refers to the total momentum of the system, is nothing but the total momentum of the system. This is also, I can write it as PCM, P center of mass. This is nothing but the momentum of the center of mass. Very important formula. It looks slightly different. You should realize that by now. It is not m1 p1 plus m2 p2 upon m1 plus m2. No, there is no mass only in this. It's just p1 plus p2 plus p3 plus p4 like that till pn. It's not divided by mass, nor is it multiplied by the mass. Is that absolutely clear, everyone? Yes. Thank you guys for reminding me for having water finally. Yes. Thank you guys. Thank you. Great. So this is another important thing which you should know. Now, one more thing which comes is, if you have a system of particles, this is very, very important. This is a system of objects or particles, meaning there is one mass here, there is another mass here, another mass here, another mass here, here. So many masses are there. From outside, there could be some forces acting on it. There could be some forces acting on it from outside. These are basically your external forces. Meanwhile, there would be also some kind of internal forces between them, maybe. Okay, so there could be some internal forces. So these are internal forces. And also, each particle might have individual accelerations, but the center of mass has some acceleration, ACOM. Then you have something called as the Newton's law. Newton's law for a system of particles. See, when you have a simple mass, simple force and acceleration, you write F is ma. But here there are so many masses, so many things moving differently, different accelerations. So which force will this be? Which mass will you be talking about? Which acceleration are we really talking about? So that's why there is a modified law for Newton, and that says forget the internal forces, just look at the external forces. The net external force will be the total mass of the system, multiplied by the acceleration of the center of mass. Very important law. So, the net external force causes the acceleration of the center of mass, causes the acceleration of the center of mass, and is not affected by whom? Internal forces. is not affected by internal forces. Very, very important. I'll show you a beautiful application of this in the previous problem itself. See, we solved this question by finding A1 and A2 separately and then using ACM formula. What if I told you there is another method for this? Say for example, I choose my system as this. This is my system. For this system, external forces are this thread which comes from outside gives a tension. This thread will also give a tension. This mass is pulled by the earth. Earth is outside the system, so mg. And this 3m will experience 3 mg. This center of mass will have some acceleration, which I call it a center of mass acceleration. So now forget any other internal force. Since acceleration is down, downward direction as positive. So using net external force is mass times acceleration. External forces are mg, 3 mg. Tension is opposite, even the other tension is upward. So minus T is the total mass. What is the total mass? What is this mass? This is the mass of the system. It will be m plus 3m. What is this acceleration that we are talking about? This is acceleration of the center of mass. Perfect. But if you remember from Newton's laws, this tension formula I had already given you 2 times mass 1, mass 2 divided by mass 1 plus mass 2 into g. So what will this be? 1 plus 3 is 4. So this will be 4m. 2 3s are 6. So 6m square g. Mm cancels. 6 by 4 is 3 by 2. So 3 by 2 mg. That is the answer. 3 by 2 mg. Is that right? So substitute tension as 3 by 2. By the way, mg plus 3 mg is 4 mg. Minus 2 times of tension. Tension itself will be 3 by 2 mg. Here, m plus 3m is 4m. And acceleration of the center of mass, I need to find out. Acceleration of the center of mass, I need to find out. Okay, so this is 4m. What is the force going to be? 2 cancels. This will become 3. 4 mg minus 3 mg will be just mg, guys. Will be just mg. Perfect. Do you see mm cancels? So what will I get a center of mass as? It will be g by 4. Exactly what we got over here. G by 4. So this is a true example of how Newton's laws can work even for multiple particles. Just that you have to consider external forces only, and the acceleration that you get is not any particle's acceleration, it is a whole system's center of mass acceleration. Got it? Such a beautiful question, and it has been done 2 ways. This is the first way, this is also okay. This is the second way, this is also okay. So you can try out both methods in multiple problems and will be surprised to see how things work. All right. Another beautiful question coming up on your screen. The masses have some speeds. There is a spring. Every other surface is smooth. No other forces. Can you find the acceleration of the center of mass? Come on, quickly. Can you find the acceleration of center of mass? This velocity is v1. This velocity is v2. Maybe in the given terms. Very nice question. Come on, my dear students. Find the acceleration of the center of mass. What you should do is consider your system. Who is your system? Center of mass. That means this is our system. This whole thing, the spring, masses all together. Who are the external forces? Think about it. Well, there is a weight, there is a normal. there is a weight, there is a normal. Spring is internal. Spring force is internal. Spring force is basically internal, so don't even worry about it. Tell me, in the horizontal direction, the external forces are not there only, and in the vertical direction, normal balance is mg, so that is 0. Here it is 0 because there are no forces only, and in the vertical direction, y-axis, they are basically, the net sum is 0 because they are getting cancelled. They are basically getting cancelled. Either ways, net force is 0. So if net external force is basically a big fat 0, what will be the acceleration of center of mass according to this equation? If LHS is 0, RHS must be 0. So the center of mass acceleration will be a big fat 0. So this M1, M2, V1, V2, K directions didn't matter. Got it? Understood? Shall we go ahead to the next question? Yep. Shall we go ahead to the next question? Now, next question is where a person will walk on a boat, or a monkey will climb a balloon, or some things will shift. Question is, find how much will the other mass shift by. Those kind of questions. So those questions where the center of mass is going to be at rest even after individual masses shifting, even after individual masses shift their location. In those kind of problems, what would be happening is the net external force would be 0, because of which the center of mass acceleration will be 0, because of which the velocity of the center of mass will be constant. It is not moving. If the center of mass is at rest, it stays at rest because it is not accelerating. If it is not accelerating, no net force. So that is the logical thinking. Now, what is velocity? What is velocity of center of mass? It is nothing but m1 v1 plus m2 v2 mn vn whole thing divided by the total mass is basically, as per this, will be 0. So numerator is 0. Velocity is displacement by time. So mn displacement, nth displacement by time is equal to 0. So then what will happen? Time cancels. So you will get m1 s1 plus m2 s2 plus mn sn will be 0. This is again a very important equation. When is this true? This is true if velocity of center of mass is 0. Velocity of the center of mass is 0, then m1 displacement 1 plus m2 displacement 2 plus mn displacement n, their sum will be 0. Also they are vectors, so sign sensitive equation. Let's see some questions based on this. Imagine there is a nice rock over here, and then we had a nice plank over here, perfectly balanced, and we have an amazing pandu over here, and we have an amazing champa over here. It's perfectly balanced, which means the center of mass is exactly over the rock. Everybody getting this point? The center of mass is exactly over that particular rock. Beautifully balanced. Now what happens? Pandu says, listen, we have to get out of this situation. Champa is like, okay, we attended Shreyas Sir's class, so let's solve this problem. Pandu says, I will move so much. Champa, you have to move this much. Champa says, okay. Champa says, listen, I am moving now, you also start moving. So that is the question now. Pandu's mass, let's say 40 kg. Champa's mass 60 kg. If Pandu moves by, let's say, for example, 30 centimeters left, how much Champa moves to remain balanced? To remain balanced. That is the question. This word remains balanced. What does it mean? Your center of mass should not move. So that means center of mass is at rest. So this is where the center of mass is, and it should stay there. And the moment center of mass is at rest, I know what formula we can use. If VCM is 0, I can use M1 S1 plus M2 S2, like that is 0. Got it, everyone? I know Pavam Champa 60 degrees. Sorry, not 60 degrees, 60 kgs. Don't ask me why Champa is more than Pandu now. Whatever. Okay. So M1 S1 plus M2 S2 is equal to 0. This is coming up directly from this result. We just saw this. If center of mass is at rest, individual masses shift, use this formula straight away. So what is mass 1? Pandu's mass. How much is it? 40 kilos. Displacement of Pandu. How much did Pandu move? 30 centimeters towards the left. So minus 30. Now you'll be wondering, sir, this is kg, this is centimeter. I say, don't worry, because this equation RHS is 0. So if you put this kg, this centimeter, kg, centimeter, so make sure all the terms are in kg, centimeter. Okay. Hi, Shravana Selvi. Welcome aboard. Yep. So Pandu is maintaining his mass, I know. Yes, that's why I kept it as 40. I remembered the older mass. Mass 2, Champa 60. Displacement, I don't know, is equal to 0. This will be negative 1200 plus 60 S2 is equal to 0. 1010 cancels. So 6 times of S2, 120 negative on the other side becomes positive 120. 6 goes with 12 2 times. So S2 will be basically 20 centimeters. So Champa has to move only 20 centimeters. Answer was positive. So that means towards the right. Champa moves where? 20 centimeters. Left or right? It's a positive answer. That means towards the right hand side. Got it? This is how you solve the problem. Everybody got it? Everybody got it? Understood how to solve this question? Hi Murugan. All right. Let's solve a monkey balloon problem. Monkey balloon problem. Okay, so what happens over here? So this is a monkey, that's a balloon. Okay. Monkey's mass is m. Balloon has a mass of 4m. The length of this particular rope which is there, so the length of that particular rope is given to be, let's say, 10 meters. 10 meters. That's the given thing. Question is, if the entire system is at rest, net forces are 0, everything is balanced, okay, then if the monkey climbs the rope, how much will the balloon come down by? Obviously it has to come down because center of mass has to be preserved. So that is the question. How much will the balloon come down by? Length of the rope is 10 meters. Now, in such situations, again, the center of mass should stay wherever it is. So, if the center of mass was here, it stays here only. So, let's say this is the location of our center of mass. The center of mass should stay there only, it should not move. So, the monkey might go up, the balloon will come down. That's what should happen. Now, let's assume, again, starting from this, velocity of center of mass is 0. The moment it is 0, I will say m1 s1 plus m2 s2 will be 0. Let's take upwards as positive direction. Mass 1 is of monkey, so it is m. Displacement s1. Mass 2 of the balloon 4m. Displacement s2 is equal to 0. mm cancels, so you will get basically s1 plus 4s2 is equal to 0. Now I know you guys are thinking, sir, I think you missed something. Why did you not put displacement of the monkey as the length of the rope, which itself is given to be 10 meters? Oh, why did I not put S1, displacement of the monkey, as 10 meters? There is a simple reason for that. The monkey has not climbed 10 meters. We're like, sir, the monkey will get mad, sir. The monkey will get angry, sir. It will scratch us. It will jump on you if you say it has not moved 10 meters. I'll say, yes, it has not moved 10 meters because you are sitting outside and observing it. Don't forget that monkey might move 10 meters for the balloon, but the balloon is coming down. So for you, it might not actually move 10 meters. So you need to be little bit careful about that. So what exactly might happen is, it might look something like this. Something like this. So, this is technically displacement 1. The balloon has come down. I hope you can see that. That is displacement 2. And this whole thing is 10 meters. This whole thing is 10 meters. I hope you saw that. Yep. Now you'll be like, sir, then what exactly is S1? What exactly is S2? I'll tell you what, just think in terms of the balloon's frame. If you are the balloon, you'll be like, sir, I'm not balloon, sir, I eat very less. Just imagine you are the balloon. You see the monkey down. You will see the monkey climbing the rope. So the displacement of the monkey for the balloon will be 10 meters upwards. Think about it. Displacement of the monkey for the balloon, it climbs that rope of 10 meters, that is 10. With respect to the balloon, not with respect to the ground. And SMB is SM minus SB. You're like, sir, where did you get this from? From relative motion. V12 is V1 minus V2. S12 is S1 minus S2. Displacement of monkey is S1. Displacement of balloon is S2. So that is 10. Okay. So therefore S1 is 10 plus S2. Perfect. So instead of S1, I'll put 10 plus S2 over here. Instead of S1, I'll put 10 plus S2 over here. So just coming back. Plus 4S2 is basically 0. So what happens next? Let's have a look. This will become 5S2 will become minus 10. So S2 will become minus 2 meters. Don't get scared, sir, I got negative, sir. Don't worry. Upwards was positive. That means the balloon comes down only, as expected, comes down by 2 meters. As expected, the balloon has come down by 2 meters. Is that clear? Students from the forest are new admissions. I think soon we should have Mowgli also running around naked in our class. Yes, we'll do that very soon. Cool. Okay, so beautiful question, beautiful concept on just this formula. And this was dependent on Newton's law of particles. And that also we have applied for some questions. So that is your center of mass and its motion and the applications in different places. We saw the snake problem, we saw the potential energy of a big body problem. We also saw, how to find the center of mass in different cases. Now, there is one last type of problem which I would like to do, and that is addition and subtraction of masses. So, you might have a body attached to another body, and you have to find the combined center of mass. Then, the x coordinate of the center of mass is given by m1 x1 plus m2 x2 by m1 plus m2, where this body is m1, this body is m2, this is center of mass of 1, center of mass of 2. You are adding both of them. Such a thing is called as a composite system. Composite system. Whereas you might have things like, there is a body, you have built a cavity in it. You have punched a hole in it. So, the original mass might be m1, the cavity which was removed might be mass m2. In such cases, the coordinate of the center of mass is the bigger mass which is existing, the mass which has been removed, so minus m1, m2 x2 upon m1 minus m2. So these are those problems where cavity is involved. Something has been punched out. So let's do some examples on this so that you get an idea of how to do these problems. Say for example, you have a square sheet and then you have this semicircular disc. This is having a side length of A. Given that this is the origin, this is x-axis, this is y-axis, find the location of the center of mass. This is a question where two bodies, composite bodies, are merged together. You have to find the total center of mass. This is like a sheet. So we'll use sigma concept over here. If you forgot what is sigma, let me remind you right over here. We did a problem where lambda was involved. We'll now do a problem of sigma. We'll also involve a question of volumetric density. So that will be our second example, where we will have probably a sphere, and from that sphere a hole has been, another sphere has been taken out. Okay, so this is R, and this is x-axis, this is y-axis, this is origin. So this is a solid sphere with cavity inside of it. The question is, find the location of the center of mass. Okay, that is what the question is. So we'll solve these two questions, guys, so that you understand how we solve the questions of composite versus cavity. So in this situation, for composite, first break the body into two parts, whichever part it is being made of. If you look at the first part, which is this part, I will call the mass m1. I will call this part mass as m2. Center of mass of the square will be here. Center of mass of the solid disc will be here. What are these coordinates? Not that difficult to figure out. This would be obviously distance wise. This would be obviously A by 2. If this is A, this is exactly at the center. So this is the center of mass of the square. This is the center of mass of the square. That's where it is located. This is the center of mass of that semicircular disk, and I think we figured it out in one of the problems, if you remember correctly. We figured it out in one of the problems right over here. Yes. For a disk versus an arc, for a disk it was 4r by 3 pi using this formula. Do you remember it? So this is 4r by 3 pi, no doubt about it. So this is 4r by 3 pi. That is center of mass of that semicircular disk. Perfect. That is done. Now the actual masses m1 and m2, how do I find? Because I'll tell you what is the problem. When I write x cm, actually not x, y cm, because it will be the y coordinate. So y cm will be m1 y1 plus m2 y2 upon m1 plus m2. The problem will be I won't know m1 and m2 only. They are not equal. Pathfinder is more than enough for NEET Shyam. Yeah, it is J level stuff, but it will definitely be enough. It won't be equal, so I have to find m1, m2. So I have an idea. Guys, mass per unit area, it is sheet. It will be the same. So if you look at the disk, the mass is m1. The area of the disk is pi r square, radius itself, pi r square by 2. Here, for the square, the mass is m2 upon the side square, which is a square. Okay. So therefore, m1 will be, take this guy on the top, sigma into pi r square by 2. But wait a minute, what is the radius? The radius is a by 2. So it will be a square by 4. So it will be sigma pi a square by 8. What about mass number 2? Take this a square on the top, it will be sigma a square. Perfect. I got mass 1 and mass 2. Let's substitute it over here. Mass number 1, sigma pi a square by 8. It will also come down, sigma pi a square by 8. Mass number 2 is just sigma a square. Here also sigma a square. That's about it. And into y1. Coordinate of the center of mass of 1 is 4r by 3 pi. So 4r by 3 pi plus y coordinate of mass 2, negative, it's down. So minus a by 2. Remember, this was origin x, y, so it is down, so negative. That's it. Now many things are going to get cancelled. Sigma, 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 a square, a square, a square, a square. 4 and 8 becomes 2. Okay, so let's see what does it become then. I have, oh, even this pi and pi also is getting cancelled, guys. Even this pi and this pi also just got cancelled. So what do I get? Observe carefully. R is there, definitely. 3 into 2 is basically 6 minus, yes, okay, minus a by 2, perfect. Whole thing divided by, this is pi by 8 minus, sorry, not minus, plus basically 1. Just check this out. That is what it is. But wait a minute, I know radius is a by 2. Radius is a by 2. So a by 2, so it will become a by 12 minus a by 2. Remember, this radius was a by 2. Divided by pi plus 8 divided by 8. Now do the math over here. LCM is 12. LCM is 12. So pi plus 8 whole thing divided by 8. This will go 6 times. 1 minus 6 is minus 5. So this is minus 5 by 12. So this will just become, is that right, everyone? So this will become minus 5 divided by 12. And you have pi plus 8 over here. And that 8 goes on the top. 8 by 4 is 2. 12 by 4 is 3. So it will be minus 10 divided by 3 times of pi plus 8. That is the answer. Got it, everyone? Manohari, when you are a part of the pro subscription, right, you get my micro courses. But I suggest you to join the DNA batch because DNA has all my classes. So I think that will be better. And if you are wondering where the DNA batch is, it's right over here in the description box. You can buy it with the test series or the Tatva module or just the only DNA batch also. That option is there. It's for 3,000 rupees. That is one option. Other option is with the test series, year-long test series. That is for 5,000 rupees. And with test series as well as the hard copy Tatva material, that is for basically 7,000 rupees. All the three options are there. You can watch my older classes as well as the newer live classes. Is that okay, guys, everyone? Why is this answer negative? Don't get scared. That means the center of mass is below this line. Last problem, this one. How to do this? This diagram where only this much part I have to shade, this much mass is remaining, is technically this whole thing minus this thing. Minus this thing. This whole thing minus just this thing. Is that right? This whole thing minus this thing. How do we do that? Okay. We know the formula for the center of mass, guys. When you are having cavities, xcm, because it's on the x-axis, center of mass will be on the x-axis, m1 x1 minus m2 x2 by m1 minus m2. The problem is what is m1, what is m2 and all of that. So let's do that part. Okay, first of all, let's see where the center of mass of the first big circle is. It will be here only. This guy's center of mass will be here. This coordinate will be obviously 0, 0. This coordinate, just think about it, this whole thing will be r, guys. This whole thing is the radius. So the center of mass will be at r by 2, y coordinate will be 0. Y coordinate will be 0. What about mass 1 and mass 2? These are solid spheres, so I should be worried about volumetric density, rho. So rho will be whole mass, which I call it m1, this is m2, whole mass by the whole volume, which is 4 by 3 pi r cube. The same thing I can do it here. It's mass 2 by this volume, which is 4 by 3 pi radius by 2 cube. So what will mass 1 be? Mass 1 will be, take rho and multiply with this. So rho into 4 by 3 pi r cube. How much will mass 2 be? Multiply this thing with this. So rho into 4 pi r cube, whole thing divided by 2 cube is 8 and this is 3. So 3 into 8 basically. So 3 into 8. Is that right? So that is m1 and m2. So substitute it over here. So the big term is going to come rho 4 pi r cube by 3 rho 4 pi r cube by 3 multiplied by 8, this thing plus, sorry, not plus, my bad, minus, below also same thing, rho 4 pi r cube by 3, yep, rho 4 pi r cube by 3 multiplied by 8. Now put the coordinates. x1, first coordinate is 0, wow, 0. The next coordinate is r by 2. Let's see who all gets cancelled. This whole term just became 0. Forget it. Rho, 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 4 pi, 4 pi, 4 pi, r cube, r cube, r cube. Okay. 3, 3. That's about it. Okay. So what am I left with? Observe. This is 0. So minus. R is remaining on the top. 2 into 8 is basically 16. 8 2s are 16. Here nothing is remaining. So just 1 minus. Here only 8 is remaining. So 1 by 8 of course. So minus r by 16 by 1 minus 1 by 8 is 7 by 8. So this 8 goes with 16 2 times. Correct? This particular 8 goes with 16 2 times. So I will be left with minus r by 2 by 7. 7 2s are 14. So minus r by 14 units. So negative means the center of mass will be somewhere over here. That is what it means. At a distance of r by 14. So that should be the answer for this. Is that clear, everyone? Clear? Everyone understood how to solve these kind of questions also now? Yeah. So problems with cavities, that too with volumetric density. Problems with composite structure with areal density. Linear mass problems, that also done. So all models I have covered, guys, in this session. This is how center of mass will be. A silent killers chapter. So I hope you enjoyed this session. We have covered all the concepts. Now it's time for you guys to practice your PYQs, practice your basics and scale it up. And once the, this month or probably Diwali, after that we'll be just going and focusing only on problems and revision. Okay. So make sure you are tuned into the channel. Make sure watching each and every class in detailed classes. You are sharing this channel because this is the channel for all the students who want to learn for NEET. All right, along with your board preparation or even for droppers, right? So in English. So do talk about this with your school friends as well. Thank you so much. Thank you for subscribing. Thank you for liking and see you in the comments. God bless you all. Hasta la vista. Do let me know how you enjoyed this class. Take care.